Hi, it's new test instrument teardown time. We've got the new Keysight EDU34450A 5.5 digit multimeter. This is part of their new educational series, as you've seen in the new giveaway videos that I've done. And it's probably the most interesting of the three new instruments. They've got a new educational power supply and a educational model function gen, 20 meg function gen as well. And they're both the function gen and this multimeter are in your traditional oscilloscope, like, you know, short, compact. Well, when I was a boy, oscilloscopes were never like this thick, like, you know, they're out here like this. But anyway, the oscilloscope form factor, basically they're reusing the tooling for their 1000 series oscilloscopes, which you can get like an EDU version of the oscilloscope. And the whole idea is that they provide these 4 instruments for the educational market as all part of one big educational package so that you can equip a typical bench. So I thought this is probably worthy of the first teardown just because it's interesting form factor. So let's check it out. First of all, you may have recognized the number, the 34450A. They're actually reusing a product number. You can, well, you used to be able to, don't know if you still can, but you can buy the 34450A 5.5 digit multimeter, and it doesn't look anything like this. It's a big OLED display one, and like, why? Why reuse it? Why the confusion like that? Like, they didn't even call it B or anything, but it's got the EDU on the front. So having the EDU on the front, exact same part number, it's a totally different look and feel instrument. I don't get it. But it's $696 US dollars. So yeah, anyway, it looks like an oscilloscope, and you can see that they've reused the tool in here because it's got a fan outlet here, but there's no fan in it. So yeah, LAN and USB as standard. Well, you're either going to love it or you're going to hate the form factor. So meh, whatever. Anyway, you know what we say here on the EEVblog: don't turn it on, take it apart. Except Flathead's not going to do it. Hang on, is it a 5.5 digit or is it 5 to the power of a half digit? Got the self-tappers into plastic down here. That's not pretty. Well, they felt for all the world like self-tappers, but they weren't metal-threaded inserts. They just had lots of Loctite on the bottom of them. So don't get your feels versus reals mixed up. So it looks like we've got all the basic shielding you expect. Whether or not this is identical to their oscilloscope, I can't exactly remember offhand, but sucker should lift off. Yep, we're in. And there you have it. Wow, isn't that nice? That looks pretty schmick. Got our processor over here and our multimeter measurement capability on a separate board. Very nice. And a good old-fashioned transformer in there. Look at that. Old school. You don't see that much these days. Brings a tear to the eye. Anyway, I do like the cable management in there. That looks pretty groovy. Not sure what the deal is going on there with that connector, with that like inline spade connector. It's all terminated very nicely, doing all the right things. All your groundies down there, I'm sure they're all Loctited. We've got ourselves a ferrite on the output here, and big ass earth going over to the processor side of things. Because of course, all your multimeter section is isolated. That's why the only thing going over here is this and that. Guarantee you that chip right there is an opto isolator. So obviously not many connections. It's a complete serial interface. It'll be reasonably high speed opto coupler. We've got our big shield over the measurement front end. Got some good old school relays. I can show you a little quirk of that at the end when we power it up. Check out the front end. This actually looks really good, doesn't it? I'm actually quite surprised to see the banana jack soldered directly onto the PCB there. Got a couple of isolation slots cut into there. 2 gas discharge tubes, GDTs, thank you very much. 2 big ass MOVs here. Look at the size of those monsters. What is I forget what the rating on this thing is. It's only Cat 2. With 300 volts, which is common for bench multimeters. You almost never see a bench multimeter above Cat 2. It's just a thing for them. But, geez, Look at that. That's pretty juicy. Tell you what. And look at those big-ass diodes over there. That'd be across your fused, your current shunt fuse. And there's your fuse right there. So that'd be back-to-back diode protection. You know, they often do that with a diode bridge. But in this case, yeah, they're doing that with two big-ass back-to-back diodes. Wow. Never seen one so large used in a multimeter before. So that's pretty nice. Yeah, and the fuse, they've gone to the effort to wire this thing over. So, you know, they could have maybe chose a PCB solution there, but they haven't. They haven't skimped. I don't see your traditional current shunt. It's got to be these bad boys here. You traditionally don't see that. You usually see your bent, like nichrome type wire current shunt. Anyway, we've got a range relay here. And there's really nothing much doing over here. These are just voltage regulators, just powering some of the logic and stuff, so nothing to see there. Attention to detail. They have, someone had fun with the silicone gun. Look at that. They gunked it down. Nice.
Your patience and we'll be with you as soon.
Yes, I'm still waiting on hold if you can hear that in the background. Anyway, quick look at the processor board here. And now you've got to think that this comes from another one of the instruments, because obviously they have some sort of BNC over here. So is this identical to like the function gen board? Hang on, let me check the function gen. No, that's interesting. Both the function gen and the oscilloscope don't have anything in the way of a BNC there. And of course, look, you can see up on the metalwork there, they actually have the BNC on the back like that. Maybe on the function gen version of the oscilloscope, I think, might have that. But obviously, reusing that processor board, as you'd expect, like, they'd be, you know, crazy not to reuse the same board. But anyway, the earth wires just, they've just soldered it into there. So they've gone, bugger it. We need to, you know, get a big-ass earth wire over there. And, well, that's one way to do it. There's nothing inherently wrong with that. Anyway, I won't bore you with the details. There you go. You can read that for yourself. ST ARM micro, what variant it is. You got the memory and you got the flash and you got the whatnots and yeah, not much else. There's that the Ethernet, yep, and USB and well, not much else. There you go. Is that the LCD flat panel driver? I don't know. It hasn't got many connections, has it? But yeah, it's really not much happening there at all. And well, you wouldn't expect anything more. And if you have any doubt that they're reusing the metal chassis there, well, there you go. There's all your inputs for your 4-channel scope. Nice. Well, you know, why not? All right, so I've taken the cables off, taken out a bunch of screws, and gotten rid of the fuse holder, and that should just lift out. Careful with the banana jacks. They've got to lift out vertical. And ta-da! There you go. There's the flip side. Oh, we can now take the metal shield off. Very nice. Check that out. There you go for you jack aficionados. There's none of that split jack rubbish. This is interesting. They've got a sneaky little bugger ferrite bead there. Here's it. You can see the trace. This is on one of the inner layers. Buggering off like that. And looks like it's going under the ferrite bead. Yeah, okay. It's only Cat 2 rated, but yeah, why you'd just rely on a layer for that sort of insulation. Bueller, Bueller, Bueller. What the heck is going on here? It looks like some sort of touch switch, but it's not, because it's like it doesn't actually connect to anything. As far as the case goes, it's like around about here on the case. It's just like, it's not that. So I can only think that it's some sort of elaborate, you know, open air PCB spark gap. But what does it connect to? Oh, like mains earth or something? It could be. It could be. I'm going to have to buzz that out. That would be my only guess, because it's nothing to do with the input. It's not like some spark gap, because they've already got like real spark gaps here. It's nothing to do with that. But here's the thing, neither side of this actually connects through to the shield here, and you might think, okay, it'll connect down through to the chassis ground through one of the posts here, one of the mounting studs, right? But look, there's your isolation around your stud there, there's your isolation around your stud there, that one, the only ones that are actually have something connected to them are these two down here. Sure enough, there's a 100 ohm resistor to mains earth there. So where's that going? Yeah, okay, we've got 100 ohms in series with a MOV here and in series with a spark gap. And then that buggers off. Oh, yeah, then that goes then the other side of the MOV. So you've got a spark gap and a MOV in series by the looks of it. And that goes, so that's your positive input terminal. That's your ground input terminal. But then the other side of that MOV goes over to this spark gap in series with, series with this MOV, which goes to your 100 ohm resistor, which then goes to your mains earth. So there actually are overload clamping that down to mains earth. Nice. By the way, all the input switching relays here, they've all got isolation slots between the coils and the contacts. Nice touch. And here's a nice little touch. They're your 3 slots for your shield. I just unscrewed it there. And you'll notice that this one will slide over, and these will slide over like that, and then it just drops out. Nice design. Right, so there's our big ass AC input coupling cap for AC measurements here. They've got a CADIC resistor divider here, so that's for the ranges. So, you know, that's what you expect. You expect that in any 5.5 digit plus class meter. You can't, well, you can do it with discrete parts, but it's much nicer to do it with a ceramic array. So no surprises there whatsoever. Here's our 2 input strings here. These are for the sense lines here. And of course they whack them in series for extra voltage standoff, of course, because each one will be a couple hundred volts and, well, 200, 400, 600, 800, 1000 volt rating. All right, so it looks like this is our another input string here, and that little inductor there, let's jump over the via for that, is there. So that's coming from this relay here. Classic ULN 2003 relay drivers here, and they're buggering off to drive our relays. So you can see we've got our coil side here, and here's our measurement side. So, whoops, oh, there you go. You got one sneaky little bugger coming off there and going through. Can we see other sneaky little bugger traces going off? So yeah, this is interesting. On the contact side, I'm not seeing any parts on those relays there. And on the bottom side, down here, you can see some internal traces there. But apart from that, not much doing, is there? There's nothing exciting to see there. All I can see is this little one buggering off over to here. Just one thing I notice here, just from a routing point of view, you can see these going off here to drive the coils, they drop them, they're on the top layer here, traces on the top layer, they bugger off to an inner layer and just go over and drive the relay here. Oh, why? I'm not seeing it from a voltage, clearance, creepage reason, so they're doing it again here. I don't know. Oh no, now I see. You're probably screaming at me in comments, it's very faint. You can see this is like the AC coupling, AC coupling caps here, but here's another input resistor here, and it's actually going on an inner layer under these 2 resistors here, and over to one of the contacts on this side of the relay. So yeah, that's interesting. Why run them under something that's clearly on, you know, you want your, once again, they're relying on the thickness of your PCB layer there for your voltage clearance. I'm not sure why you'd do that. Right, so we've got our 4 relays here and our 4 inputs. This relay here connects to the AC coupling cap. This relay here connects to a 100 ohm resistor there in series. This relay here actually connects through to the high end of the ceramic resistor divider there. And this relay here connects through to this high voltage resistor array here. So there you go. There are our 4 separate choices for our inputs. Yeah, I just don't know why they've gone under the resistors. I don't know. Okay, Dave, tell us how you would have done it then. Well, okay, clearly I would have, these would have stayed on the top like this. They go directly over to drive our coils over here, and then I do what you're doing here. The contact actually comes through the center here like this, and then I would have put an isolation slot here and here, so I could get, because these are our contact size, so this is a double pole, double throw switch. We've got one switch here, which connects between there and there and there, and this one there, here and here and here, and yeah, I would have all taken them out around like that and then put the isolation slots in there, but they haven't. They put isolation slots here and here and then run the trace under there and relied on the thickness of your layers between your PCB. I don't get it. Anyway, here's the interesting bit. Check this out. They've got a Keysight custom jobby here, and we haven't seen this in other Keysight bench meters. It might be in the other, because I haven't torn down the other 34450A, the one with the OLED. Maybe it's absolutely identical design to that one. They've just changed the form factor and the user interface and stuff like that. Anyway, you can see the little exposed guard traces there. Of course, they do that for leakage reasons. You probably have to do a video on that dedicated to that one day, but we're seeing that on low measurement stuff. You see that in your femto amplifiers and all sorts of stuff. Anyway, I don't know if it's genuine Keysight custom silicon or whether or not it's a rebadged one of your traditional multimeter chipsets. That would be interesting to find out. If anyone out there, and I'm sure there will be a lot of people interested, will, I don't know, check out the pinout of something like that. So, high-res photos on the EEVblog Flickr account, linked down below. So anyway, that's going to contain our ADC, of course. That's, your traditional multimeter, like a dual slope or multi-slope integration converter. It's going to have the range switch, and it's going to have all the other functionality for resistance mode and capacitance mode and, all the other stuff. So that's your traditional multimeter chipset. And really, there's not much else doing. With the relay drivers, as I said, what's that one? Oh, that's just a DG412 Mux. Nothing doing there. What are these bad boys down here? And a couple of LM393 comparators down there. But do we have some bridge rectifiers there? Nothing doing. Someone will say, what's the brand of the electrolytic cap? JH? Can't say that rings a bell. And before anyone screams, oh, there's no PTCs in here, they've got the MOVs and the GDTs and everything. Well, no, they've got one down there. It's on this input string here. Of course, they don't need it on all the input strings because, well, it depends on the functionality that they're trying to measure. But anyway, let's have a quick look at the input circuitry around here. Once again, we've got a couple of 393 comparators there. A bunch of Ds for diodes. They're not transistors. They're all diodes. So a bunch of diode protection and whatnot, and just a bunch of passives. And of course, all your multimeter aficionados are asking the one question. Sorry, I had to get this far into the video before you saw it. The voltage reference, of course. No, this isn't a 6.5 digit meter, so you're not going to get your, LTZ 1000. Sorry. You're going to get a Renesas jobby, although that's got a Fairchild on there, but it's all Renesas these days. I don't know who's gobbled up who. Anyway, it's the 21090, and this is a voltage reference available in different voltage standards, and it's like 0.02% at best initial accuracy, but of course the initial accuracy doesn't matter because you can calibrate that out. What matters is the drift of the thing, how many ppm, tell us ppm, 7 ppm. So debate in the comments down below whether or not that's good enough. Is it good enough for a 5.5 digit meter? Is it overkill or is it just adequate? And then we've got another ARM processor there. We've got a buzzer up here for your continuity. We'll test that now because there's nothing left, really. You could probably hack away there. There you go. There's some headers. Don't have a connector on there. They're being a bit naughty. But anyway, the JTAG's there. It's all labeled. So knock yourself out. So the conclusion on that is that, yeah, it's pretty schmick. They've got, all the dedicated paths with the relays in there. There's, no sort of like range switch and other compromises you need to do in handheld multimeters. So they're just separating out all the functions there, and it all looks, relatively good. Of course, only 300 volt Cat 2 rating. You're not going to, of course, because this is mains powered, you're not going to carry it out with you in the field or to a switchboard or, to some big power plant or something like that. That's not its job, but looks like it has more than adequate protection, and you can argue away about the voltage reference and whatever. I assume it's custom Keysight multimeter chipset silicon down in there, although I don't know, somebody may have helped them out. Maybe they commissioned it from one of the multimeter chipset manufacturers, perhaps. I don't know. Is it the same? Is this almost identical to what's used in the existing OLED model in the more traditional bench multimeter case? The one that's, the 34450A without the EDU on. Is it basically an identical circuit? I don't know. Never opened one. Still works. Takes a bit of time. It's going through its cycle there. And, yep, we're in. Now here's one of the quirks. The absolute first thing I noticed when I plugged in this meter when I actually got it is that, here you go, it's just sitting there. We've got our 5.5 digits, measuring 1.8 millivolts. It's supposed to do that. So my BM786 over here, it's measuring something, you move the probes around. Done a recent video on this. This actually spurred that recent video on the number of power line cycles. So I take these probes, I plug them in here. Yep, there it goes. It's doing exactly the same thing. Oh, there we go. It's just cycling through. It's just cycling through. Yeah, it's switching, and that's 10 mega ohms input impedance. I switch it to auto, which is high impedance mode. It still does it. And if we go to a 1 volt range here, it just overloads because it's picking up the 50. Oh, no, it didn't do it. There you go. Oh, overload. Because it's picking up the 50 hertz. Actually, let's go into fast here. Because it's picking up, there we go, it's picking up the 50 hertz noise in the lab here, and it doesn't have the number of power line cycles set to at least 1. Whether you're in fast, slow, or medium, it still actually does this. And if you set it to auto range, actually, if I untwist the wires, I think that's why it's not performing like it did the other day. Listen to that relay. Look at that. It'll really depend on how the leads are, how much 50 hertz I've got at any one time. That poor relay. Anyway, I do have a video of it actually doing it continuously, and I sent it through to Keysight. Anyway, that's just, something to be aware of. And from what I can find in the menu, or can't find in the menu, there is no ability whatsoever to set up number of power line cycles. You got, auto, it has an annoying default auto dim where the screen dims. Jeez, why bother? There's just nothing in there that I can find for number of power line cycles. Anyway, we do have a secondary measurement capability DC current. So it looks like we can measure, because we've got the different jack, we can measure current and voltage at the same time. Beauty. Continuity. Here we go. This is what everyone wants to see. Multimeter still has to have a fast auto ranging. Oh, that's so slow. Yeah, not for an everyday use meter. But then again, we are on slow mode. Let's put it on fast. Let's see how fast she actually is. Here we go. Go up. Looks like it goes up to 100 meg there. Whoa. Hey, it's just flapping around in the breeze there. 100 meg? Hello? That could be the noise. That could be related to the 50 hertz pickup, I'm sure, because, this is going to be greater than 100 meg. Oh, yeah, there we go. We're instant. Oh, yeah, look at that. Look at that bad boy. No wuckers. And the continuity buzzer, let's give that a burl. Well, it's quick, but it's so piss weak. I can barely hear that, and I'm in a silent lab. It's like 10:30 p.m. here, all silence, and geez. Compare that to my BM786, same distance with the microphone pointed away. Huge difference. Looks like it's got 0 ohms compensation, so we could null that. Oh, okay. Pre-math. Oh, look at that. Oh, isn't that fancy-pantsy? 0 compensation. There you go. Look at that. Oh, nice. Anyway, unfortunately, one of the things this thing doesn't have is your fantastic trend plotting, like live trend plotting that you get on the other Keysight bench meters. Unfortunately, it doesn't have it. You can actually do data acquisition though. So, you know, if we go into DC volts here, we can actually acquire, and we can go into continuous, and then we can go into data log mode, and we can trigger, and we can have trigger count and sample interval and data log on like that. And the minimum sample interval you can do is 1 second by the looks of it. I can't seem to go under that. Okay, so if we data log on, and then we can run, there we go. So it's sampling once every second there, but it's not going to give us a display. So, okay, so we can just stop that. Then we can go into display, and we can view our log. And there you go. That's just the 50 hertz input crap that we were seeing there. And yeah, there we go, one at a time like that. And that's basically all you can do. But of course you can export, like you can, because this thing's got full remote capability, LAN and USB, and I believe you get the software with it, although I'm not sure if it's full capability. No, I don't think it is. No, I think it's only like the demo capability of the software or something. Like it needs to have, there it is, that bloody relay again. Needs to have trend plotting in it, just like the other Keysight meters. Come on, you've already got the software there to do it. Like, why can't you include it? I don't know. I know it's probably extra work to include it, and you should get the full license to the software as well. So anyway, look, I'm not going to do anything more with this. I want to keep this video under 30 minutes. This is not a full review. If you do want me to do a full review, I can eventually do it and have a look. Oh, we can have a look at capacitance here. Let's go over, but look, it's like I'm not sure how it compares with the 344 for the previous 34450A, but well, it didn't have trend plotting, I don't believe. So yeah, maybe that's what, like, everything's just nicked from that, and that's one of the problems. Like, one of the main draw cards of the Keysight bench meters is the trend plotting capability, and being able to do that, and not being able to set the number of power line cycles on a bench meter with, like 5.5 digits. Sure, it's not a 6.5 digit meter, 5.5 digits. And while Keysight might do a firmware upgrade, they have already done a firmware upgrade since I reported the auto ranging thing. They fixed a few things, but it's still there, because I don't know, I've probably got a lot of 50 hertz here in the lab. But yeah, no, you can't have your relays just flicking around with, it needs to have the ability to set the number of power line cycles. Just set it to 1. Or have the user option to do that, and you'd never get that. It just wouldn't pick it up. So yeah, I don't know. It's like, a lot of people are going to like the form factor. They're going to probably like the price point as well. It's not that expensive, but then again, it's not that far off their 6.5, like their low-end 6.5 digit models and other, 6.5 digit models on the market. So, but anyway, yeah, there might be specials on it or something like that, and it's a lot of people are going to buy it for the form factor and for the remote capability and all that sort of stuff. You can script things and do everything, and the hardware seems pretty decent, but I can't help but think that they've just stumbled on a few hurdles here, and just lacking some features that could make this a real killer multimeter, I think. I don't know. Leave your thoughts down below. Am I right? Am I wrong? Being too harsh? Oh, no, that'll, eat into the sales of their 6.5 digit ones, etc., etc. And it's only designed for the educational market, and, yeah, okay, but, it's probably only software things, really. So, I don't know. Anyway, that's the teardown of the new EDU34450A 5.5 digit bench multimeter in an oscilloscope form factor. If you liked it, Give it a big overexposed thumbs up because of the Keysight Black. Look at this, bloody Keysight Black. Put my hand in there and it's just, sure, I'm a white pasty nerd, but geez, you know. Anyway, catch you next time.